Since the industrial age, fossil fuels have dominated energy supply and consumption in most parts of the world. The energy derived from coal, oil, and natural gas has powered our everyday lives, driven industrialisation on a massive scale, and transported goods and people around the globe. It's been the fuel around which we have designed our vital infrastructure, and our technology evolved to rely on it. Dismantling our reliance on fossil fuels will be no easy task, but it's one we must complete with urgency. Emissions from burning fossil fuels are responsible for 3/4 of the global greenhouse gas emissions in any year. And if all the known fossil fuel reserves were burnt for fuel, the CO2 emitted would be 3 times more than the remaining carbon budget, which is the maximum amount of CO2 we can emit and stay within even 2 degrees of warming. So meeting any of our climate targets means we have to end our dependency on fossil fuels for energy.
We're starting from a base that's already had, a century's worth of investment, and we're at that cusp now of having to redesign, reinvest, and recreate a whole new energy infrastructure. In many ways, this is the 21st century challenge that needs to be addressed, and in so doing, we can have the excitement of reimagining a low-carbon energy infrastructure fit for the public's use, fit for industry and business use, and fit for decarbonising our economy.
In this episode of Getting to Net Zero, we will explore the transition to sustainable energy from a systems perspective. We'll look at the global picture to understand the challenge ahead, the policy priorities for high-consumption nations, and meet the people creating new ways forwards on the ground. The energy system is everything required to power our manufacturing, transportation, our buildings, and most of our activities. Energy must be generated or extracted from natural resources. It must then be made available at its point of use. Different end uses require energy in different forms. Most of our energy still comes from non-renewable sources such as coal, oil, and gas. The rest is produced from either renewable sources like the sun and the movement of water, wind, and tides, or from nuclear energy. Between generation and consumption, there is a complex industrial sector for converting between different fuels. This is required to store energy or convert it to a form that is usable across the range of things we need energy for. Globally, this adds up to a highly complex infrastructure network of generation, supply, and use. But this is a global picture. There are many different kinds of energy system around the world. The way that energy is generated, distributed, and consumed is shaped by environmental, economic, and social needs, natural resources, and existing infrastructure. But there is a vast disparity between the amount of energy used by the world's most intensive consumers and those with little access to it. The highest emitting 1% of humanity have an average carbon footprint 75 times larger than the average footprint of the lowest emitting half of the global population. That means that transitioning to a sustainable energy system will look different from place to place. But when it comes to high consumption societies, there are some common principles for finding and prioritising solutions. The first priority is demand reduction, curbing excessive energy demand through combined economic, infrastructure and lifestyle change.
Very often we concentrate our efforts around the supply side, and that's understandable because of the ageing infrastructure that we need to replace and the scale of investment that's required. But the demand side of the equation is also critically important. If we can control and manage demand, then of course the supply side is not so stressed.
There are choices people can make to reduce their consumption, in particular, transport choices. But demand reduction has to be built into government policies, like supporting innovation and adoption of low-energy products and processes for both industry and consumers, preventing large-scale energy waste by reviewing economic incentives, and even reducing how far people need to regularly travel through town planning. When it isn't possible to reduce demand, we need to make sure the energy we do use is used efficiently and not wasted. This is often technological efficiencies like car and jet engines, which use less fuel, or insulating buildings so that less energy is used to heat and cool them. Minimising demand and maximising efficiency would make it much easier to then provide all the energy we need from only zero carbon sources. But our demand for energy is still growing, and growing faster than zero carbon generation is, meaning that our demand for fossil fuels is still going up each year. In Wales, a team of designers and engineers have created a prototype building that hopes to help reduce that gap between supply and demand. Their active buildings are capable of generating, storing, and even controlling use of their own energy.
The difference between an active building and a building that just has, say, solar energy technologies on the roofs or walls is the fact that we've also got energy storage and smart controls. So that enables us to control when energy is imported to the building and when energy is exported from the building. Potential benefits of this active building approach is that each building becomes its own energy system, which can then be connected up to lots of other energy systems or buildings, so that instead of just having a centralised source of energy, we've got all these smaller decentralised sources which are all able to work together and choose the right source of energy to use at the right time.
This decentralised approach can also change people's relationship with energy.
Currently, we all just take energy for granted, so we don't necessarily relate our own individual houses to the bigger picture. With active buildings, the building user or building owner becomes really an energy prosumer, so we're producing energy as well as consuming it. And I think what that does is connects people to their energy. People are more aware of where their energy is coming from.
While this prototype uses solar energy, that's not the only way of doing it. In fact, a lot of time is spent debating which kind of zero carbon energy we should focus on. But the reality is that meeting our demand with zero carbon energy will need all of them, and a lot of energy storage. No single technology will do everything, and each is suited to different places and different energy systems. The key is designing a sustainable energy system that meets local needs.
Many of the energy infrastructures that we see in society today are based on a hierarchical model of large centralised stations. We have to now think about new architectures. We have much more broadly distributed energy sources. So in many ways we now have to invert the challenge again. So being constrained by the conventional architectures will limit our opportunity to reach that low carbon future. So this is where engineering and technology and innovation and design of a new low carbon energy system will be critically important.
This decentralised approach is being made into a reality in rural India, where the Green Switch project, run by Tata Capital, is building energy systems for isolated communities.
What we aim to do from the project is to provide a long-term solution which would probably transcend our own lifetimes, right? And that is what we are trying to do here, future-proof a particular problem for these communities. So instead of switching them first to a conventional thermal source and then probably, reintroducing a new technology, we thought it would be better to introduce a clean form of technology which is affordable for these communities directly.
The communities provide the land, install the microgrid infrastructure provided by the project partners, and receive training to maintain the system.
Key to the entire thing is the community. Because this the model that we are trying to build is a community ownership model, the community plays a key part because they will finally own the microgrid.
The communities involved have seen many benefits. One of the big changes is that families no longer rely on kerosene for heating and lighting. Kerosene creates serious air quality and health problems when burnt indoors.
We've seen that we've eliminated this particular source. Therefore, we've reduced other health impacts to especially women and children, which would be irritation to eyes, respiratory problems, etc. Plus, we've reduced the amount that they have had to spend on kerosene or the time that they had to travel to buy the source itself. Besides this, we've also seen that women and girls especially have taken up entrepreneurial jobs in the evenings. Some women have started their own grocery shops from their houses. They've saved money, they've bought refrigerators. They provide that service to the other houses in the same settlement. So we've seen that change and seen them grow not only in terms of how domestic electricity has provided convenience and safe living condition, but also how commercially each houses are making a little more money to save for themselves and for their children.
The Green Switch project has so far given energy access to 30 communities and over 5,000 people, but meeting the needs of all requires a different scale of ambition and resources.
It requires a huge investment, a huge effort, lots of technology intervention, finance to actually make sure that it happens on the ground. You're talking about billions and trillions of dollars of support to developing countries, and frankly it is required because just given the scale of India, okay, it's just one country with such a huge population, and electricity is just one issue, and you cannot talk about anything else if the communities don't even have electricity and water and food. Just the basic living conditions are not met.
Adequate provision of clean energy is not a simple challenge with a single solution. We've seen how energy is involved in nearly everything we do and every technology we use, and how our energy needs and the best way of meeting them vary massively by geographic and economic context.
Of course, at the heart of this net zero journey is a commitment to sustainability. And I'm a great believer that one of the most sustainable fuels is optimism. And when I speak to my students or my colleagues or my industrial partners, having an opportunity to create the future is a real driver for participation. And if I had a very clear message for policymakers and indeed industrialists and innovators in society itself, is that it's in our will and in our control to participate and collaborate, to design, to invest in, to create and live within that new net zero future.
Join us in our next episode, Transport, to continue our series of video explainers on how to deal with climate change by harnessing a whole system transition to net zero, guided by justice and enabled by engineering.